right, so let's look at factoring expressions. When we're factoring expressions, we're always going to have two different types of terms in our expressions. We're going to have a variable term and a constant term. A variable term is going to have a variable attached to a coefficient. So, for example, 32x would be a variable term, and a constant term is just an integer, either a positive or negative integer. So 4 would be a constant term. So let's use the expression 32x plus 4 for my expression to factor. Now when we're trying to factor expressions, we're going to be trying to identify the greatest common factor of my variable term and constant term. So let's write out the factors of 32x, meaning the numbers that multiply to get 32x. I know I have 1 multiplied by 32, 2 multiplied by 16, 4 multiplied by 8, 8 multiplied by 4, 16 multiplied by 2, 32 multiplied by 1, and also x is going to be a factor. Now let's do the same thing for 4. 1 multiplied by 4, 2 multiplied by 2, and 4 multiplied by 4. So these are my factors of 32x and 4. Now we're looking for the greatest common factor. We're looking at the ones that's the highest of these two. So I notice that 4 is the highest in this group, and 4 is the highest, meaning that they're the same. That's the greatest common factor between the two. So now I know I can divide each term by 4 when I'm trying to factor. So let's go back and factor this now. So 32x divided by 4 is going to give me 8x on the inside. Now this number right here, that is our greatest common factor when we're factoring. The greatest common factor is on the outside of the parentheses. You're taking it out. So now I have my 32x divided by 4 gives me 8x. This is addition, so it's going to stay addition. 4 divided by my greatest common factor is 1. And then I close it back up. And a quick way to check to see if you're correct, you can always go back and re-multiply your greatest common factor by each term inside. 4 multiplied by 8x is definitely 32x. 4 multiplied by 1 is 4, and it checks out. So this is when I only have two terms. I have one variable term and one constant term. Let's say I have 3 terms in it now. So let's look at that. So we're going to have more than one variable term, and we're going to have a constant term as well. So let's say I have the expression 14a plus 7b subtract 21. Now in this case, I have two different variable terms. 14a is a variable term, and 7b is a variable term. And now I have one constant term, but my one constant term is negative 21 because the subtraction sign is attached to it. So now what I need to do is I need to find the greatest common factor between all three of these. And using some quick, simple mental math, I notice that 7 goes into 14, 7 goes into 21, so it looks like I can divide 14a, 7b, and 21 by 7. So 7 is my greatest common factor. That's going to be on the outside of my parentheses. So 14a divided by 7 gives me 2a left. 7b divided by 7, that's just going to leave me with b, because 7 divided by 7 is 1. So just imagine there is an invisible 1b, a 1 in front of the b. We really don't need that, so we could just say it's just b. Now negative 21 divided by 7 is negative 3. So my factored expression of 14a plus 7b subtract 21 is 7 in parentheses 2a plus b subtract 3. And again, if you want to double check to see if you're correct, you can always multiply your greatest common factor by each term inside the parentheses. This is also known as the distributive property, which we have seen before and which we will be using later on with expressions as well. But just to double check, just a real quick, 7 multiplied by 2a is 14a, 7 multiplied by b is 7b, and then 7 multiplied by negative 3 is negative 21. So that checks out. So this is factoring expressions when I have more than one variable term.